Good morning, everyone, and welcome to today's webinar. My name is John McLean, and I'm a sales and marketing executive at TruckScience. Optimizing payload is a crucial step in any commercial vehicle operation, whether it's in the design, manufacturing, or operational domain. This webinar will cover some of the principles and techniques involved in this process and aim to answer your questions about why, when, and how to apply them. It includes a live demo using Class 3 and Class 8 vehicles. So let's get started. So today we'll be using 3 real-life examples to illustrate ways to optimize payload. So first will be a Ford F-350 with a service body and center axle drawbar trailer carrying machinery equipment. Next, we'll use a Kenworth T380 with refrigerated van body carrying palletized freight in a multi-drop operation. And lastly, we'll use the Kenworth T380 again, but this time with a tanker body carrying diesel and gasoline. So I'm just going to pop over to our axle weight calculator now to go through these examples. Okay, so as I mentioned there, firstly, we'll design a truck operating in California. So I'll just set up the regulations to validate against this. So I'll go up to my settings wheel and go to regulations applied, and I'll clear what's there initially. And I'll go for California state and interstate roads. So all 50 states are catered for at an interstate level, and a lot of states are catered for at a state road level. And we're constantly adding new ones on request. We also recently released all Canadian provinces. It's also possible to pin attributes of the vehicle that we might be interested in. So here, I'll just clear what's there initially. And here I'm going to pin the tongue weight on the vehicle as a percentage of trailer weight, because we will be using a trailer in this example, and the gross weight on the vehicle front as a percentage. Okay. And we can also define ranges for particular attributes that our organization is comfortable with. So for safety, we might have a percentage here of tongue weight as a percentage of trailer weight. It's actually already set up there. So if it goes outside 10% or 20%, it'll be flagged, but I'll show that later on in the example as well. So I think everything is okay there. So I'll click OK and move on. So as I said, we're going to be using a Ford Super Duty 4x2, and I'll just take the exact model there for my notes to save a bit of time with this 60-inch C8. Okay, so you'll notice here that the front and rear chassis weights of the default spec have been pre-populated, and we see some basic information here on the weights table for the chassis, along with relevant dimensions here as well. So for anyone that's actually new here, I'll just quickly go through a brief overview of the actual interface here. So the information we see here, the drawing dimensions, chassis weights, and axle ratings, etc., have been sourced from the Ford Bodybuilder portal. We have a data team who are constantly adding and updating vehicle specs in this library. So just a few more pointers. On the left-hand side here, we can add our vehicle, our body, equipment, payload, trailers. Down here on our dashboard, we can verify with manufacturer's ratings, regulation limits, and our own organization's internal standards, and to display our favorite measurements. Our weights table over here to see detailed weight distribution and compliance information, and to determine maximum achievable payload. Because this vehicle doesn't yet have a body, the payload is 0, but we'll be adding a body soon. On the right-hand side, we'll switch views and examine outputs. And along the top, we can print, save, and share our calculations. So I'm going to, we'll start adding components now to this build. Just take a quick drink of water. Okay, so let's add a body to this vehicle. So we go over here again on our left-hand side to add body. We'll go to service body, and I'll actually, again, choose a napide, but I'll take the one from my notes. I'll take this one. If I wanted to custom design a body, I could have gone for a service body template, which would give me more free reign in terms of weights and dimensions. When I click into this Nap by Body, you can see that I can't actually change or manipulate any of the dimensions, but with a template you could. If I was a body manufacturer also, I could import a DXF drawing of one of my bodies in my range and choose to make it available to distributors via the TruckScience platform. So we can also add, let's add a crane to this as well. So we go to equipment, go to crane, and I'll search for a lift more here. Okay, we've got our crane there. So I'm going to drag this crane to a more suitable position. But just as I do that, just keep an eye on the weights table just below the drawing there, and you'll see it change as I move that crane. Actually, this will be a good opportunity as well to show one of our new features, which is left-right distribution. So if I go up here to my settings wheel and go to preferences, I can now tick this new box for left-right weight distribution. Click OK for that. And now I'll just go to top view to show you, or you can see there at the bottom of our weights table, the new feature. I'll go to top view. I'll grab this crane and drag it curbside and just keep an eye on those numbers in that new field in the weights table. So you can see we're fully utilized there on the right of the rear axle. Okay, I just quickly wanted to go through that, but I'll flip back to side view and I will just switch that off again because we won't be needing it for this example. Okay, so now let's say for argument's sake that we have a diesel engine that needs to be collected from a building site and brought back to the workshop for repairs. So we can actually add that diesel engine here. So I'll go to vehicle payload, click detail payload, and search sample diesel engine. Okay. Okay, so taking a look there, we're reaching our maximum capacity there on the front axle. So if I was to take that and drag it more towards the front axle, you'll see that it will become overloaded and the app will flag that. But what I want to do is I want to put it to a more realistic vertical position and try and get an even distribution over those axles. So I'll drag it actually, excuse me, one sec. I'll drag it back to this position and you'll notice that there's an more even distribution over those two axles now, where it's around 78% each, roughly. 76. I can also I'll add a trailer now to this as well, but to do that I'll need to add a hitch. So I'll go to my add equipment. I'll go to Pintle Hookler and I'll add my sample tow hitch. There it is, and I'll just drag that down a little bit. Okay, so now we'll add our trailer. So I actually clicked this trailer together myself using the trailer template feature, but I won't do that for now. I'll just use this one I already created just to save a bit of time. Okay, so you'll note there that the trailer has flagged that we're no longer complying with our organizational standards that we set up in the beginning. If I drill down into that, we can see that it's the tongue weight as a percentage of trailer weight. That's out of range. That's to be expected now as we don't have any payload on the trailer. So I'm just going to add some payload to this trailer as well. So we can go here to payload, detail payload, and I'll add a bobcat. And I'll just take that bobcat and drag it back a tiny bit. Okay, so note that the vehicle now is actually overloaded due to the additional weight transferred via the hitch. And our tongue weight at center trailer weight is also being flagged there in our organizational standards again. Um, so it's meant to be, remember we set it to be between 10% and 20%. So it's actually outside that range now at 29%. So this percentage is a crucial factor in the stability of a vehicle and ensuring that the driven axles have sufficient traction. It is important to comply with the hitch manufacturer's recommendation when speccing a combination like this. So we can actually move this Bobcat back to see what effect that has. So I'll grab it and you'll notice now we will comply hopefully. So we're not overloaded there and our organizational standards should go to a green tick once we get below our, or get in between our 10 and 20%, which are at 15.4% there. Okay, yeah, and now, well, once we've spec'd this vehicle, you can generate a PDF for our customer. So if we go up here to the top and click Generate PDF, it just cause it to take a little bit longer. But so this PDF will show you the different placement of the Bobcats. It's got different views that you can actually set up in preferences, what you'd like to show. It shows the placement of, say, the diesel engine. And actually, while I'm here, there are actually a few more features that I can show you that we've added. So now you can add your signature. Currently, I can use this one instead, say. You can add your signature to your PDF document, which is quite handy. And there's also rubber stamps that you can add to it to say that say approved, but there's a variety of different ones and markups as well. So you could pin something on the drawing that you'd like to talk about and leave a little note there as well. Oh, so yeah, I think that's my first example done anyway. So Jens, is there any questions at this point?
No, there aren't any questions at the moment. But feel free to type in your questions at the bottom of your screen. There's a Q&A button, and if you just type in your questions there, I'll try to answer them or offline, or I'll get John to live answer them.
Yes, definitely. Feel free to ask as many questions as you need to. Okay, actually, while I'm in the habit now of showing new features, I'm going to show another feature here that we have added also, which is the unloaded vehicle weight. But to do that, I'm going to need to get a vehicle that is 10,000 pounds or less. So I'll just find one here. I have one prepared. Okay, this one. Okay, so we've got our drawing here. So if I go here to weights and axles and go to total, you can see that our gross vehicle weight rate of this vehicle is 9,070. But now our new feature, which is max UVW, which is unloaded vehicle weight, is 7,500. So the program calculates unloaded vehicle weight or UVW. The UVW is verified against the maximum UVWs stipulated by the chassis manufacturer where applicable. So I just quickly wanted to show you that before I moved on to my next example. Okay, so for our next example, I said that we'll design a refrigerated truck to transport palletized freight in the New York tri-state area. So first of all, I'll go back to my regulations to set up the regulations for that. So regulations applied, I'll just get rid of those and I'll go for New Jersey, interstate, New York, interstate, and Connecticut. So the attributes in the attributes, sorry, that we might be interested in here would be we'll go for the gross weight on the vehicle front as a percentage, the body plus payload on the front of the vehicle as a percentage, and on the rear as a percentage. And I won't pin any organizational standards for this drawing. Okay, so I said that we would use a uh, Kenworth T380 um, 6x4 and this one here. Okay, so the first thing that we're going to do is add a body onto this, and we'll go for a box body, and we'll go to our add body and go for a box template. Okay, so by default, the width of this is going to be 94 inches. So I'll just go to my top view to show that. But in order to increase that, we'll go to the legal maximum here of 102, just so we can get as many pallets on that floor as we can. Okay, I'll go back to my side view. Okay, so we'll add now a refrigeration unit. So if I go back to add my equipment, go to refrigeration unit, and I can go, I'll add a Thermo King T600. Okay. Okay, so we can see immediately now that that fridge unit is going to interfere with the cab. So we're going to have to increase the height of our body. So I'll take our body height there and I'll bring it up to say 117. Okay, we also have an issue there with so the app has flagged an issue there with the overall height. So I'll reduce that just a little bit uh, to 115. I'll just bring it down another two, 113. So for those who know their regulations in the tri-state area, there is a 13.5 foot limit, which we do now comply with. So to complete our configuration, I'm going to add a tail lift onto here as well. So I'll go back to add equipment, to our plus icon, go to our tail lift, and we'll add an Antio F3 CL22C. Okay, and you can see all of those populate on the weights table there as well. So now that we have our vehicle configured, let's add the payload. So we said that we're going to use palletized freight. So if I go over to add payload, go to detail payload, um, I can go to a GMA pallet. And I'll just drag that back just a little bit for airflow. That's probably a bit too far, actually. I'll just take it back a little bit. Okay, so we can also change the weight of this pallet. So if I click on it and go to weight, I'll change it from 2,000 to 1,850 pounds. Uh, and now what we can do is we can actually go to our top view and we can duplicate these pallets. So if we click on our pallet here and press the copy button, so I'll just move this so you can see it generated up. So watch as they create onto our drawing. Okay, and I'll take this one, number 8, and drag it back. Okay, and now we can copy again. And just keep an eye on that weights table and notice how our distribution is changing over our axles as I add these pallets on. Okay, so now that I've got the pallets on, you can see that the app has flagged an overload here on our rear axle. And if I drill down to our regulatory compliance here, so we can see that we are now illegal in New Jersey and New York, but legal in Connecticut. So we would have to offload some pallets before crossing the state line. So let's do that. Let's take off number 14 here. And we'll take off number 7 as well. So we'll take off 2 pallets. Okay, so now we can see that we're actually the opposite. So now we are legal in New Jersey, legal in New York, but illegal in Connecticut. So we can see that we're overloaded here on the front axle as well. So something we could do here to solve that problem is just take these pallets and drag them back towards the rear. And again, keep an eye on that front axle percentage of utilization as I drag them back. So this, the one in red. So I'll drag that back too. So it's gone to 104. We're going to 102. So we're going in the right direction anyway. I'll take one more pallet and pull it back, and hopefully that should be enough. Nearly there. Just a little bit further. Okay, there we go. So now we are legal again in all those states. So just a few other things to note. I'll go back to my side view. A few other things to note there as well as the various center of gravities. So I can go to my center of gravity view here just to show you that. So you can pin your center of gravity view for say the body and the refrigeration unit and also the antio there. Okay, so if we're okay with all of that, again, we can create our PDF, which will have our load plan on it for the driver, uh, which will give them a nice overview of where to place these pallets for a multi-drop route. And I'll just wait for that to load again. Okay, so you can see here as I scroll down, we can see where to position all those different pallets, making it a little bit easier for the driver. So Jens, I'm just going to ask you again at this point if there are any questions.
Hi, John. Sorry, I'm busy answering all sorts of questions.
That's good.
But at the moment, I've been able to answer them all via the chat, and there's nothing for you to demo at this stage. But
Okay,
yeah, so
no
yeah.
problem. Cool. I'll go through my last example. So, and again, I'll give another opportunity to answer questions too at that point if anyone can think of if anyone has any questions that they need answered. So again, I'll go back to home here. So this time, uh, I'm actually going to be using the same Kenworth, so I didn't need to click out of that. But yeah, so this time we're designing a tanker to serve the greater Chicago area. So I'll set up the regulations for that again. So again, we'll go back to our regulations applied. I'll clear that and I'll go for Illinois state and interstate roads. For our favorite measurements, we'll go for the gross weight and vehicle front as a percentage as well, and say the vertical center of gravity of the vehicle overall. So, like, so for safety reasons, so we can actually take our gross weight on the vehicle front here and we'll pin that. So we'll stay gross weight on the vehicle front as a percentage. So we'll try and keep that in between 20% and 100%. And again, if we go outside these zones, it'll be flagged. And we'll do the same here for the vertical CG of the vehicle overall. We'll try and keep that between 0 and 70 inches. And I'll explain that later as we go on. Okay, they look good. I'll click OK to that. And again, I'll go back to my Kenworth T380, 6x4, and this one. So we're going to have to make some changes to this Kenworth though to suit a tanker body. Just give it another second to load. Okay, so we're going to have to shorten this wheelbase from 252 and we'll bring it down to 230. Oh, that's not quite right. 230. Our after frame also needs to be adjusted, so we'll take this and reduce it down to 73. Okay, so we need to double check the impact of the chassis reduction on these axle weights with the dealer. But for this exercise, I'll just estimate them so I can change these chassis weights. So I'll take that from 8,300 down to 8,100, sorry. And then on the rear axle, down to 6,600. Okay, so now we're ready to add our tanker body. So again, we go over here to our left-hand side, add body. With the tank, we'll add a tanker template. And I'll just drag that a little bit back from the cab, just about a few inches. It's a bit too far. That's all right. Next, so we'll add some pump and metering equipment. So I'll do this by adding a template. So if I go here to add my equipment and go down to other, I can add a template here. If I had a DXF drawing for this equipment, I could use that. But templates still give you perfectly accurate results if you populate the data correctly, that is. So I'll just change some of the figures here. So our height, I'll change to 25, our width to 30, and our position of this will change. Actually, I'll change the weight also to 2,000 pounds. And our position from the back of the cab, so minus 34 inches. And above below the chassis, minus 30 inches. Let's see how that looks. So there it is. I'll also name it as well, just to, so it comes up in a nicer format on our weights table. So pump and sure. Okay, see there it pops up in our drawing. So now that we've configured our vehicle, let's take a look at our maximum achievable payload that has been auto-calculated for us, which is about 27,500. So this assumes the tanker has a single compartment for now, but we'll add compartments later. We can see the limiting factor here is the rear axle. And if we drill down to the permissible here, it's taken from the lesser of the bridge or the regulation and the manufacturer's rating here. So depending on where you're operating the vehicle, you could get more out of that rear axle. But in our case, we're limited to 34,000. So the payload is going to be around 27,500. So now let's tweak the center of gravity of the load to see what effect it has on the maximum achievable payload. So if I click here uh, on our payload, I can actually change this. So if we change the load center and we move it forward, we can see here if we reduce our center of gravity by about 5, I think it's set up to reduce by 5. Okay, so you see you lose there about, is it 3,000 pounds of payload. So the payload does start reducing, but I'll just undo that for now, just to show. So let's make this example a little bit more realistic and add a few compartments to our tanker. So we can do this by going over here to adding our payload and detailed payload again, and adding our generic payload template. So we can create 3 different compartments for our tanker. So I'll have to adjust these measurements. So our dimensions here, so for our length, I'll go for 72 inches. Our height will be 60 inches, and our width, 96 inches. And for this one, we can do our weight. So we'll actually do this instead, since it's going to be a liquid, we can do volume. And we'll estimate the density for this first one, which will be diesel, as 7 pounds per gallon. And the quantity here will be 1,300. And I can call this, let's say, diesel tanker 1. And I can just copy this again like I did before with the pallets. Okay, but we don't want them all to be diesel, so I'm going to take this second one here. Well, I'll go to the last one first maybe and just change that name to diesel number 3. And go to our second one and make this gasoline instead. So because gasoline is less dense than diesel, I'll just change the name here. Number 2. And we'll go to our weight again, and we'll do this. This is already done in terms of volume. So our density here is going to be 6 because it's less dense. But you notice, okay, so our weight is 7,800 pounds, whereas with our diesel here, it's 9,100 pounds. So with our gasoline, we can actually, sorry, go back to weight there. We can actually add a little bit more to it. So let's add 1,400 pounds there. Sorry, 1,400 gallons. So we're at 8,400. I'd say we could actually probably go up to 1,500 gallons. Yeah, about 9,000. So now each tank is roughly weighs the same. So now an issue to consider, as was with the previous scenario, is ensuring that the vehicle remains legal now at various drop-off points. So when we pump diesel, say, out of this last compartment, so let's say we pump the whole tank empty, and I change this quantity to 0, you'll see now our front axle actually become overloaded. So because of the center of gravity shift. So that's something to look out for. So instead, what you could do is you could just take half out of that tank, so half the amount of diesel, and then out of our front tank, go back to our weight and take half out of that. So you're still getting your 1,500 out, but just more of an even distribution. And there you go, everything stays legal there. We should also check the overall center of gravity since we did pin that at the start. So again, we can go to our center of gravity view. Sorry, that's the bridge view. And we can see there we're at 57.5, which is well below 70 inches is what our limit, the limit that we made at the start. So lastly, again, you can generate your PDF, and that'll tell us how many gallons to pump into each compartment. Just like that. Yeah. Again, our different views there. Uh, and our center of gravity and all of our different information is going to be generated on the PDF there. Okay, that's actually the last example now, Jens. If there's any questions that I can address, or did you manage to answer them all?
Um, yes, actually, I have two things I'd like you to demonstrate there, John.
Mhm.
If you go back to yeah, just that view, yeah,
Yeah.
just click in there, um, and just go to the summary view. Yeah. So one of the questions was the permissibles. Why do the front and the rear permissibles not add up to the total permissible? So there's a couple of elements to this. And if you maybe just click into that permissible of the 51,500.
Yeah.
Um, so so I suppose in this case, or in all cases, we take the lesser of the GVWR and the bridge or the regulation value. And in this case, the bridge value is less than the GVWR. But the question also related to why does the front and the rear permissible not add up to the gross permissible? So even if the GVWR was less than the regulation, it still doesn't necessarily need to add up to the sum of the front and the rear permissible. So I suppose just to clarify that,
Mhm.
um, that's just how these things work. And then the other question was around adding a pusher axle, and maybe you could just briefly add a pusher axle to this vehicle.
Yes.
So you go to axles there and add pusher, and it adds the pusher in there and does those weight calculations. And I suppose it's just interesting also if you look at this, the payload there was at 18,000. Okay, it's not maximizing the payload because you've got those tank compartments,
Oh, yeah.
but it's calculating the distribution over the pusher and overall all as well. So we do those pusher and tag calculations. Um, yeah, and I think those are the only questions or the only two things that were outstanding, unless there's oh here's another one. Here's another question coming in. Can this show the weight changes as a dump body is being emptied in transit, like a snowplow spreading salt? Um, so the answer to that is if we I responded to probably a similar question there around the tank compartments, where we don't show the percentage kind of volume left over in the tank or the dump body, but you can simulate that by reducing the weight in the dump yourself, and it'll do those calculations as you decrease those values. Um, so I don't know if that answers your question there. Um, in fact, maybe you can just demonstrate that, John. If you remove those three compartments
Yeah.
and you just go to simple or to optimize simple payload. Yeah, so that's calculated the maximum payload as being about 32,000 pounds. Now, if you wanted to simulate the gradual unloading of that, you can change that payload value of 31,800 and you could change it to say 30,000 and see what effect that has. And you can change the load center. So obviously, if your load center changes, that has an effect on the load distribution. So you can toggle that and do those calculations. But unfortunately, we don't have an animation or something like that to demonstrate that. Um, any other questions? Okay, John, I think that's it.
Okay. I'll move back to my slides, but once I finish my slides too, I'll give just one last opportunity to um, for any questions if there's any outstanding ones there. Okay, so to sum up, here are a few of the topics to consider when optimizing payload. So as we saw in the examples, the jurisdiction that you operate in is a major factor. The choice of chassis is obviously fundamental. The modifications you make to the chassis, be it the wheelbase, afterframe modifications, or adding axles, are also very important. Adapting your body design to the payload you're carrying is crucial. So experimenting with materials, weights, and dimensions. Adding a trailer can increase payload significantly if it suits your operation. And finally, positioning the various components in different positions to come up with the optimal placement. So if you'd like to try the Axle Weight Calculator app yourself, you can visit TruckScience.com to register for a fully functional 7-day free trial. And yeah, just before I completely wrap up there, Jens, I'll just ask one more time if there's any questions, because we do have a minute or two left, I think.
No, there aren't any more questions as far as I can see.
Cool. So I will end this webinar shortly. But before you go, please rate the webinar and leave any comments or questions you'd like to share with us. If you'd like to set up a personalized demo of the app, just leave your contact details in the comments, and I will gladly set that up for you. So thank you very much for joining us today. We do look forward to your feedback, and goodbye.